So when you're going to prove, you're going to have your main strategy in your mind. At the same time, you're going to look for shortcuts. So in this one, I have cos on this side, cosecant on this side. One of them is squared. So because one of them is squared, I would look at my identities that have the squared and ask myself, does it look like it would be easier if I changed the cosecant squared to cotangent squared plus 1? Not really, because I don't have any cotangents on this side. So it might work, but it doesn't. Initially, I look at that and I go, it doesn't make it easier, it makes it bigger. So then I go, okay, well, I'm going to try the regular strategy. The regular strategy says change things to sine and cos, and then get a single fraction on both sides. Now, the first dilemma I'm going to present you with in this question, we know that cosecant is 1 over sine. So cosecant squared would be 1 over sine squared. Now, what does your brain do with the 2? Does your brain do this, or does your brain do this? One of them is right, and one of them is wrong. And this is where, if you haven't tried questions, you don't realize where you go wrong. So one of the things that we want to do in our proofs is have opportunities to make mistakes, to find out where our brain is mixing up fraction rules, so that we can learn from those mistakes and not make them again. Okay? Well, in order to see which of these is right, let's take it a little bit slower. Let's take it a little bit slower by putting the 2 there and then just changing the cosecant squared to 1 over sine squared. This is multiplying fractions. The fraction in front is a 2 over 1. How do you multiply fractions? You multiply the tops, you multiply the bottoms. So the 2 would stay on the top. But you will be tempted to move it to the bottom when everything else is going to the bottom, right? It's like peer pressure. Hey, we're all going to the bottom. You want to come? The 2 stays. Okay? On this side, how do I add fractions? I need a common denominator. Initially, this seems like a bad strategy because you'd have to multiply this one top and bottom by 1 plus cos theta. And this one you'd have to multiply top and bottom by 1 minus cos theta. So it seems like you're making things bigger. And that sometimes feels like the wrong thing. But in the main strategy, we need a common denominator. When we look at this common denominator, we have a difference of squares. 1 plus something, 1 minus something. So if I multiply that out, I would get 1 minus cos squared theta. And on the top, I'm adding my fractions now that I have a common denominator. Add the tops, I would have 1 plus 1, which is 2, and cos theta plus minus cos theta, which will go away, and you would just have the 2. So it does make it nicer and simpler. And the nice thing is now my numerators are the same. I have a fraction on both sides, and my numerators are already the same. So you don't want to build the other side because you already have something the same. We just need to get our denominators the same. And what can I do with 1 minus cos squared theta? I can change it to sine squared because that's just my big idea with one mental math thing where you move the cos squared to the other side. So now we're done. sounds fun, eh? Did I give you the questions yesterday from question 2? No? So just, you can do 12A, you can circle. I'm going to, yeah, we'll do question 3. We'll do question 3 right now.